Yeah, we're live. So missed it by 4 minutes. Sometimes prep doesn't go the way you expect. And whenever I'm rushed and trying to get it done right before 7 o'clock, all of the stuff decides, hey, look, I think we need to slow down and take a minute, including sending photos back and forth and accessing things. And the computer decides, hey, look, I'm not doing this. It doesn't matter to me that you want to get it done by 7 o'clock. That's not on my timetable. So that's what happens. But tonight we're going to talk about a couple of things. One is the, excuse me, one is the video that I just put up today, and that is the 700 horsepower big block stuff. Most notably, I think for a lot of people seems to be the most popular one is the fact that making 730 horsepower on 87 octane. Because let's face it, if we can do what we need to do in terms of performance, and we can do it like with cheap gas, that just makes it even better, right? And the key, and all this is a little bit of a spoiler alert, but the key is low compression and lots of cam timing. So, everybody's going to talk about dynamic cam timing and or dynamic compression, basically based on the cam timing. And that's really what does it. I mean, we could have done it with a different camshaft, obviously, but having a 540-inch motor, aluminum heads, like 8 or 8.5 to 1 compression, and then a 270 plus, cam duration at 50, it makes it pretty easy. It's not really a big deal. In fact, I've seen stuff that goes into 4 digits that's actually run on 87 octane too. So you can make a lot of power with that. The interesting thing, and the thing that people will bicker about, I'm sure tonight and in the comments, I haven't checked all the comments yet. But I have seen a few of them, and they say the following thing. Oh, well, because I posted this on Instagram and Facebook as well. And so the consensus is, well, if you run if the comparison is which one makes more power. So we'll talk about that a little bit tonight before we get into our camshaft stuff for the Brian Tooley. Well, really any kind of truck cam, but the data that I have is from the Brian Tooley stage 1, 2, 3, and 4 that we're going to talk about. But on the 87 versus 91 octane, it was an interesting test because everybody thinks, well, you can make more on 91 because you can put more timing in it. No, that's just a generic thing. That's a generic statement that's not accurate. It's true that if you ran into a detonation threshold point, that you could probably run more timing on 91 than you could on 87. But in this particular situation, that wasn't the issue. The issue here was we had such little static and dynamic compression that we were able to run this thing in the way that I did. It was run the motor on 91. Run as much timing as I needed to until we didn't make any more power, and then leave it there. And then we played with air fuel, and it ran best at 12.7 or 12.8, which is kind of typical of these combinations. And then I drained all the 91 fuel out, put 87 in. We made a couple of runs just to purge the system, so it didn't remember that it had octane. Because I've had somebody tell me that actually, which was kind of funny, kind of awesome, but also kind of funny. And then we ran on 87. I didn't change the jetting because the air fuel, that's a big thing. A lot of guys, the 91 octane, the burn rate's going to be a lot different. No, that's not. The burn rate and the octane are not actually that's not a causal effect. It's possible for those to change, but it's possible for two different kinds of 91 to have different burn rates and two different 87s to have different burn rates, and an 87 and a 91 to have the same burn rate. And what happened here is when I ran this with 87 versus 91, air fuel was exactly the same, within 1/10 of an air fuel point. I made no changes to jetting. That stayed the same. I made no changes to timing. I ran the timing that was optimized for 91 octane with 87. And the reason that I was able to do that is because we weren't near the detonation threshold of either one of those. So we got to a point where we had maxed out the available timing with 91, and it didn't make any more power. And it did the same thing. It made basically the same power. I think that there was a variation in 2 spots of 3, maybe 4, like 3.5 or 4 horsepower or something. So in the 730 horsepower motor, that's basically next to nothing. So it's very cool that it made the same power on, you guys can argue, bicker back and forth about these little variations in spots. But to me, that's the same power because it wasn't at the peak. The peak was actually the same. You can bicker back and forth about whether or not that's the same. To me, that's the same on a 730 plus horsepower big block Chevy, making 91 and 87. And also very cool that same timing and same air fuel, despite making no jet changes. So for the guys that are saying, oh yeah, it'll change the air fuel a lot when you go from 87 to 91, no, it doesn't. It didn't do that. And I've tested that before on another application, and the same thing. It just didn't do it. Oh, but only because that's not a universal thing. Only because we had it on a combination that was already working as well on. As a matter of fact, that's going to be our poll. Now that I've already explained it, it'll be interesting to see what people do. Will a low compression big block make more power on 91 than 87? Will a low compression NA big block make more power on 91 than 87 octane? So that'll be our poll for tonight. Boom, nailed it. So that's going up. So that's that discussion. And it's always good to, whenever I bring up the 87 octane versus 91 thing. And then also you could go into the other things, race gas and the 85 and all that stuff. Obviously, this wouldn't benefit from any of that until we had the blower on. Then the 85 and extra octane would definitely come into play, which we did. We ran, I don't think we ran this airflow headed one with the big, we did. I think we ran it with a blower. I think we ran it with a Procharger later on after I'd put the airflow heads and stuff on it. So it was a good upgrade. But in that video, if you guys haven't taken a look, make sure you take a look. Also has a Vortex Supercharged junkyard heads, cam, and intake, but junkyard bottom end Gen 6. And then also no, that's on the turbo motor. The other one was run with a stock set of Gen 6 heads, just a cam upgrade on the Gen 6 motor with the Vortex YSI. And then the turbo version that made over 700, they both made over 700 horsepower. In fact, they were both like inches away from making 800 horsepower. And both of them ended up doing that fairly easily later on with further testing. But on the turbo version, heads, cam, and intake with a turbo lower boost, the Vortex YSI, stock Gen 6 heads, valve spring upgrade, small camshaft, and then lots of boost. So all of that worked out really good. So tonight, we're also going to talk about choosing the best truck cam. Now, the testing that I've done primarily on the truck cams is with Brian Tooley. And I've run the stages 1, 2, 3, 4, the Gen 1, the Gen 2. I don't know if he might have stuff that's brand new that's different. Obviously, I've run the Truck Norris cam, which is very popular, and the Torque cam also, which is good. But here's my question, and maybe we need to do another poll. I don't think I could do another one, though, right? I can only have one at a time. Yeah, I think I can only have one at a time. So the question is this. When I ran the stage 1, 2, 3, and 4 truck cams, I ran them both on a 6.0 and on a 5.3. But when I ran them on the 5.3, we went from somewhere just south of 350 horsepower with a stock cam, with a stock LM7 camshaft. We jumped up to just over 401 horsepower with a stage 1 cam. And then with the stage 4 cam, we jumped up to 424 horsepower. So with the first jump in camshaft, we picked up, 50 or 50, a little bit more than 50 horsepower to a stage 1. Going up 3 stages to a stage 4, we picked up 23 horsepower. So my question is, given those kinds of changes, and then with each successive jump up in stage with the camshaft, we also lost low speed torque, way down low, where the drivability part becomes a concern, and the converter selection becomes a concern. So if you're putting a stage 4 camshaft in your truck application, especially a 4.8, if you're putting a stage 4 in a 4.8, you're definitely getting a converter. If you're putting in a 5.3 and you're doing a stage 4, you're also definitely getting a converter. In fact, a stage 4 cam in a 6-liter is probably still not stock converter territory. The other ones, the stage 1 and the stage 2, I think a stage 1 might still be a stock converter on a 4.8. A stage 2, I don't think is. A stage 2 on a truck cam might be a stock converter, might be right on the border. On a 6-liter, I think a stage 2 still is a stock converter. All the rest of them are converter territory. So the question is, or the concern, and the choice for a guy that's wanting to upgrade the camshaft. And here's the dilemma that we have as a camshaft person, as a person with a truck selecting a camshaft for your desired application. So right off the bat, because we have stage 1, 2, 3, and 4, when you're talking to your buddies, and this is how the thought process goes when you're choosing a camshaft, when you're talking to your buddies, you know, you want to be tough and manly, and they say, well, what truck cam did you get? Guys don't want to say a stage 1. they want to say they got whatever the highest number is. If there was a stage 5, guys would be picking the stage 5. But they want to say stage 4. They can probably get away with, their ego could probably let them get away with saying, I got a stage 3, you know, because I want a little bit of drivability. And really a stage 3 does everything that the stage 4 does. That's an argument that can be made, especially with the smaller motors. I wouldn't pick a stage 4 with the 4.8 motor anyway. With a stage, with a 5.3 myself, I would pick a stage 1 or a stage 2 because it does 95% of what the other ones do, and then also offers lots of other things that I think are better. Again, my choice. Your guys, other people have their own choice. So my question is, given the minimal gains going from a 1 to a 2 to a stage 2, I think is still a pretty good gain. The 3 and the 4 are really the ones that I'm concerned about. they're really the ones that I question. And maybe because I'm not a, maybe when I was 20, I was an all-in guy and I would just get that anyway and then deal with the other stuff that was really 90% of your driving, but you didn't care about that stuff because you're all in on the other stuff. So my question is, what guys out there, so you guys that are watching this and people that are here for the live feed, you guys that are watching this, are you a stage 1, stage 2, stage 3, stage 4 guy? Like, what motor do you have? And then what stage camshaft did you pick if you've already picked one? Or would you pick if you had the option to pick one? Let's say somebody was going to give you one and you had the option of picking the camshaft that you want. You know, right away with all of them, you're going to need springs. So you're going to have to get springs. That's kind of a given. So do you pick the bigger cam, knowing not just that you're going to have the drivability is going to be different at the very least, even when it's tuned properly, it's going to be different than it would be with the smaller cams, but also more likely than not, if you go with a stage 4 cam, you're also going to get a converter. Now, there are two ways to look at that. One is that you can look at that situation as, I got a cam, oh great, now I also have to spend more money on a converter to get this thing to like work right. Because the last thing I want to do is have a guy in a stage 1 or a stage 2 truck just wax me because he had so much more low speed power and it worked better with his converter, and that he could just get the jump on me, and then I didn't ever have enough room to run him down unless we were going for like maximum speed. So we don't want that to happen. So the stage 3 and the stage 4 guys, you can look at it like you have to get a converter. You can also look at it like this. I'm a glass is half full kind of guy. So you can also look at it like I get to get a converter. And when I do, I now have made 2 modifications to my truck, both of which are going to make it awesome. One is I got the stage 4 cam, and then I can make fun of everybody that picked a lesser cam, the 3 or 2 or a 1. I mean, come on, who are those people? So I have that. And I also have a converter, which is going to definitely improve the acceleration rate of my truck. And especially matched with the camshaft, if I can get that thing to stall past the point where the other cams might have been a little bit better, now I don't have to worry about any of that. Now I have the cam that's going to charge on the big end. I have the converter that's going to flash to where it's going to put me in a point where I'm going to be accelerating probably away from these other lesser cam guys. So it all depends on how you view it. The guy with the smaller cam is going to say, oh, you got terrible drivability and there's no reason to have that. It's only worth 5 horsepower more than the other cam, and they can bicker back and forth. The other guy can say, yeah, but I have a 4 and you have a 1. So I'm at least 3 better than you. And oh yeah, I also have a converter, so now I'm 10 better than you. Because that's how car guys are. So my question for this it's interesting because like I said, we went from 350 horsepower to 401 to 424, going from the stock cam to the stage 1 BTR truck cam to the stage 4 BTR truck cam on this test motor, which is down a little bit compared to some of the other stuff that I run, certainly down from the L33 that I have now. This was done on what I think I can best be described as a tired LM7 way back when I did this testing. I also tested it on the LY6. And then the thing that I got when I tested these truck cams on the LY6 is like, nobody would run that on LY6. That's a rec port head. These are truck cams. They're designed for cathedral port heads and, yada, yada, yada. That's all just utter nonsense. The camshafts do the same thing. They did the same thing on the truck. The 1 made more than the stock one, and then the 2 made a little bit more, and the 3 a little bit more, and the 4 a little bit more, but not a whole bunch more. And you would think of anything that those camshafts, the bigger camshafts, would be even better on the bigger motor and all of that stuff. So it doesn't matter that it's a rec port or a cathedral port. When you're adding those kinds of mild truck cams, they do the same kind of thing. And the only thing that I can say is that you could probably get away with a slightly bigger cam on a 6-liter, certainly than you can on a 4.8, and a little bit more so than you do with a 5.3. The 6.0, obviously, if you have one of those, good on you, because that's a great motor. It's the other ones are much easier to find, the 4.8 and the 5.3. And the nice thing though is about any of these truck cams, and this is also why I normally recommend the smaller cams, especially with the 4.8, is it most of the people that are looking at doing these kinds of camshafts are thinking, okay, I'll put this in for now, and later on, what I want to do is the same thing that everybody wants to do. I want to add some cheap boost to this thing, so I'm going to add some sort of GT45 or S475 or some kind of VS Racing turbo on this thing later on, and as luck would have it, or by design, all of these camshafts work perfectly well under boost, and then you just have all of this gain that you have down low. And as I showed on the Truck Norris video, versus a sloppy stage 2, when you have a smaller cam and it makes more low speed power, it makes more boost response, and then and then away you go. Same thing can happen with converter. As you have a converter flash and you have that kind of eliminates some of the gain that you got from low speed power plus boost response. You can get the turbo spooled up, and all that stuff can work out. Quite honestly, lots of those combinations will work. And that's kind of been my point for the last 2 years doing these YouTube videos, especially when we're catering it to turbo stuff and really cams in general. And there are a lot of things that will work there. That's why there's so many different choices for the truck cams and NA cams and blower cams and turbo cams. A lot of those camshafts for the 1,000 horsepower stuff, a lot of those camshafts will work. Lots of stuff from BTR, which they make great stuff, and I love Brian. But also, the guys from Tick and the guys from Cam Motion and the guys from Texas Speed and Comp Cams and everybody, Clay Smith, all of that stuff. If they had, and we saw that in the test that I did for the sloppy stage 2 versus the world, which I still haven't finished in it. I think it's been more than a year now. It might be coming up on 2 years, where I ran all the NA stuff. It was disappointing to me because they just all had the same kind of power curve, which we kind of knew they were going to, because they're all similar cam specs. And that's the thing. One guy may learn something from lots and lots of testing, which I think the guys from BTR have recently. But if you have 3 or 4 or 5 cams that are all 212, 218 cams, the chances are that they're going to do they're all going to do fairly well. And really, if one of them is 10 better, when you have a turbo, does that really even matter? I mean, one was 10 better, but look, now it's not 10 better anymore. I just put another quarter pound of boost or half pound of boost in it, and now everything is good. So my question is, I'm going to see where our poll is, and maybe this will be a double poll tonight. And I got another thing that I want to get going here with you guys. Will a low compression NA big block make more power on 91 than 87? 68% saying no, and 32% saying yes. Wow. Interesting. Okay, so I want to get into one other thing, and I need your guys' help for tonight, and I'm going to put up my own money on this. I want to help I Ain't No Punk Todd. I want to help him get his stuff done. As you guys know, he's fighting cancer right now, and in my opinion, the guy's tough as nails, having met him and gone up and dealt with him. But what I want you guys to do is, for everybody that will kick in even $1 or whatever you'll kick in for Super Chats money, I will match that up to $1,000, and then I'm just going to give him the money. So, and I'll do a video on it. You guys can see it. And so I want to help him get his deal done. I honestly think that and I'm hoping that he's going to be around a long time, and he's going to be part of the group, and he's going to be here talking to everybody. But I want to help the guy. So if you guys can help out, throw $1 in there or whatever. And like I said, everything that somebody throws up for Super Chats, I will match out of my own pocket. And so if we can get some money going, I'll match whatever you guys can do. So please help if you can. It's for a good cause. So I'm willing to go to one large. So let's see what we can hook Todd up with and get him going. And fingers crossed that he's going to be around with us and do lots of stuff with us and get his motor running. Tom stepped up. Yeah, Tom, you're already costing me money. Nice. Appreciate it, man. Yes. Everyone wants to kick cancer's butt. We should. It's terrible. It's an awful thing. The question is, why is there a 6 to 8 degree duration split on LS cams? There isn't on all of them. There's a big variation in duration splits, much more on the rec port stuff. And that's because there's a bigger disparity. At least the explanation I was giving, there's a bigger disparity between the intake flow and exhaust flow on the rec port heads. That's why they have bigger splits in the cams to improve the exhaust. When I've done the testing, the cams work the same way, but the duration split is basically the reason that they give it is because intake to exhaust flow. Hey, thank you very much. You guys are kicking in here. I appreciate it. George. Yep, EF cancer. Exactly. Amos, thank you very much. I'm excited about doing the intake test with Amos with the 8.1 liter so we can get that going. And I'm curious to see what that intake is going to do. And I'm also curious to see what the camshafts are going to do. Guys are stepping up, man. I really appreciate it. GBS Garage, anything, $1, whatever. I'm in. I don't mind doing this. I appreciate it very much. And hopefully we'll get him a couple bucks. James, thank you very much. You guys are awesome. Go. Just curious, $10. Nearest link dealer to West Texas and Odessa. No plugins for Fords. Goodman, I choose a P5 Grand on my Suzuki cam from Angle Cams because I wanted more torque and mid-range. How long is this going to run for? I'll be here for an hour. James, Richard tuned to Denali with a stage 4 cam, stock converter, needed a converter, idling nightmare, but ran like a scalded dog about 3,500. James, what converter did you put in that? And was it a 6.2 or was it a 6.0? George, thank you very much. James, Ken, Robert, yeah, what's up? Boatman in the house. Not Boatman, Goodman. Goodman Boat Transport. Thank you very much. The gentleman who delivered the 8.1, and I was I felt compelled after he brought the motor all the way from Amos. Like, I felt like I should be, while I was talking to him, getting that motor and putting it on the dyno so he could see it run, so he could see that all of the effort that he put into driving that thing over, that it was like all for a good reason, and that I was going to do my part now that he's done his part. Richard, thank you guys very much. You guys are awesome. Casey, everybody has exactly the right stance on this. Look into hyperbaric oxygen with exogenous ketones. Oh, cool. I'm going to tell him, Richard. Good information. Gary, thank you very much. I ain't no punk. If you have a PayPal address, let me know. Glad to contribute, but not okay with YouTube's 30% scam. Yeah, I don't like that either, and it would be better if we just all threw it up there on his deal. Can't do any donations till Friday, and as a cancer survivor, I'd like to try. Hey, if you send best wishes, that's also awesome. What kind of capability are we talking about for link, stage, nitrous control, ADGTs, wide? What do you think about aluminum LS rockers versus stock steel rocker arms, pros and cons? I don't normally, on most LS stuff that I run, other than when I did direct like rocker tests, I don't normally replace the stock rockers. There's no reason to run an aluminum rocker unless you're doing a roller tip and it has a roller fulcrum too. Unless you're going with higher lift stuff, some of those cams will benefit from having a roller tip. Most of the stuff runs really well, and the stock rocker works very well. It's lightweight. You can run a lot of RPM on it. Johnny, thank you very much. Grooves. I do like the barrage of colorful super chats. I know, it was like I was playing pinball and I just lit everything up. It was awesome. Richard, the owner, never got a converter. When he did, it was some junk one. I told him the Circle D. Circle D does have good stuff, but he went off some brand. It was an LQ6. Okay, or an LQ4 6-liter. Good. Yeah, 30% is pretty harsh. Fall Fighter, thank you very much. Yeah, we wanted Jeff. Thank you very much, man. We're trying to help him out. Like I said, I'll whatever you guys got. If you got a buck, you got 99 cents, 50 cents. I don't care what it is. Whatever it is, I will match it. And my bank account is negative due to a paycheck issue. Don't worry about it, man. Everybody does what they can. Yeah, Ken, for the super chat stuff, they get a percentage of it. George just installed Circle D triple disc on a pickup. Very nice. 6L90E is a bit of a learning curve, though. Sent donation. Cancer touches everyone. Fall Fighter, thank you very much. I already pay YouTube for the premium service. Tom, what do you get for the premium service? Do you get to see me on a big screen? Is that one of the perks? So let's see how our poll is doing. Will a low compression NA big block make more power on 91 than 87? We got 132 votes, 164 people watching. Come on, guys. Get up and vote. Oh, YouTube Premium gets out of the basic. Okay, the ads. That's right. No ads. All right. Paul, 258, 261 duration. Is that at 50? 650 lift. Would you recommend aluminum roller rockers or stock steel? That's a fairly high lift. And I'm hoping that if those are duration numbers at 50, that's a big camshaft. Is that like an LS7 cam or something? That's normally where I see lift numbers like that, and also duration numbers like that. And if the lift numbers are for an LS7, then that's a 1.8 rocker. You can avoid ads with an extension for your browser. Email donation only in the future. For good suggestion, Ken. I made a mistake of putting a stage 4 cam in my LQ4 swap. Regarding miles per gallon, would I be able to pull off a manual swap, or do I need a higher stall converter? You can do a manual swap. That's a little more involved, but a different stall converter would help. Does anybody know what the stall converter change would, going from a stock stall converter to a 2800 to 3000, which I think is kind of typical? Does anybody know what that does to like cruise fuel mileage? Ad block plus on Chrome also gets rid of 100% ads. Nice. Is a truck Norris cam too small for a 6.2 and an Escalade? No, I think it would be a good choice for a driver. Cameron, thank you very much. We're going to make Richard pay. Great. Okay, that's enough, people. No, it's awesome. First super chat I ever sent. Well, welcome to the family. If you have a lockup, it doesn't do much at all. Went with the 2600 stall. Okay, nice. So it's still so the mileage can still be there. You guys are all awesome for the super chats. Thank you guys. Yes, it's awesome to see the community step up. Richard, the higher stall in stage 4 won't affect mileage too much when it's locked up. Cool. I didn't know if it affects where the lockup is. Barton, thank you very much. Except it's not Chad, it's Todd. But that's all good. Where's Just Curious at? Let me see. I'm gonna scroll back. Fall Fighter. Just Curious. I'm not seeing one. I'm still looking, unless it came under another name. But again, thank you all you guys for helping out. Racer D steps up. What are your dyno correction factors there? I'm asking my friend that has a dyno here in Ohio. It would depend on the barrow. I can take a look. Let me see if I can see acceleration, lambda, cylinder, atmospheric condition. 3%. The STP was 103. Barrow was 2920. Where West Tech is, it's pretty nice. You can see stuff that's like, more than 20%, 25% if you're up at altitude. Oh no, my name is Chad. Okay, best wishes from Chad. Okay, see, that's all good. That's me. That's my bad. The Circle D converters are good. Phillips 5.3 with a 10.5 to 1 compression, worked over 862 heads, 2800 stall. I went with something similar to a stage 3, not tested yet. That should work good then. JB, thank you very much. Quarter hunted, nice. I like it. Hopefully the LS2 finds its way into the K10. We better get some evidence of running in 3 months. Exactly. Admiral, we're up near $400 to $500. Man, we do have to take care of people. Richard's extra popular tonight. My dad got a 93 454 SS. I do like those. We knew it would spark knock with 87 and did a little bit better at the strip. Yeah, a lot of times the factory stuff, if you put more octane in it, then it will add more timing. And that's why I had to go over what the test was and what the results were and the combination and all that, because we had a combination that was not limited in knock at all. Not on 87 and not on 91. And it allowed us to run full timing on both of those. So we were way beyond the detonation threshold, or way before the detonation threshold. We should test the effect cranking compression has on knock. Go from a stock cam to a mid-level to an absolutely wild cam and check cranking compression. We can, and the cam timing will definitely have an effect on cranking compression, because I did cranking compression tests on a lot of the cam tests that I did, but I haven't done it on a detonation threshold because they don't have knock sensors. Robert, thank you very much. I have a set of TFS 225s to put on my 6-liter. Why do they require a roller rocker? They don't. They probably want you to put that on there so that you reduce side load, because it probably doesn't have a powdered metal guide. It probably has a bronze guide, maybe. What is I Ain't No Punk? That's one of our local guys here that comes on the chat all the time. And he's about 35 miles away from me. I've been up to see him. He's battling cancer right now, and he's also building an LS, and I've done some stuff with him. And so I want to, you meet a guy and you just, he's a car guy, and I just dig him and want to try to help take care of him. It's my birthday next month. What are you guys going to do for me? Yeah, Admiral. I wish that I did have that knock sensor data. That would be cool. Richard, you should have Todd as a guest on the show. That would be good. Just Curious, you have, okay, so Tom is trying to help Just Curious out. You have to press the little $ thing down here at the bottom and press the little dollar sign thingy, real technical. Next to the chat box, it's called Super Chats. Richard, you could just post your Venmo. Well, I put out my email address all of the time, and you could use PayPal there too if you would like. PayPal is going to take something, but not very much. KillerB16 at AOL.com. So you guys are free to use that if you want to put up a few bucks for PayPal or whatever. That all works too. And like I said, anything that anybody sends is going to the big man. Do you know any reputable shops, tuners in the Pacific Northwest and Washington State? I do know one. It's Ernie, the guy that used to work at West Tech. And Jay, send me over an email. I just put my email address down. Send me the email address, and then I will get Ernie's number because I think he's up in that area. That was the other capability I was looking for in the ECU, knock sensor capability. I would sure like to have knock detection numbers so that I had something that was concrete. The problem is that on the engine dyno, we run into all sorts of frequencies that can also trigger that. Please calculate dynamic compression ratio on a 5.3 with a truck Norris cam. You'll find you can't increase static compression ratio over 9.8 to 1 on pump gas. We can run it way over that because we're running colder temperatures. Because dynamic compression ratio isn't the only thing that dictates knock. There are lots of other things that go into that. Dynamic compression ratio is one thing, and the people that just figure it out, that become dynamic compression ratio people, think that it's absolute, and it's not, because knock sensitivity changes with water temperature, it changes with chamber design, it changes with air intake temperature, it changes with a lot of stuff that have nothing to do with the relationship between the static compression and the cam timing that you're using. That's another thing that does it also, but there are other things. Don't the knock sensors usually go out on the LM7? I don't know. Do they have problems with stuff going down in that little valley hole? I just tried PayPal your email address and it's coming up as invalid. Did I not put my email address down correctly? Let me make sure. KillerB16 at AOL. That's what my PayPal is linked to. Hey, Richard, don't feel bad about your Nova. I'm going to have an announcement tomorrow night about the Nova too. The more I wire wheel, the more rust I find under the paint. Mine doesn't have any paint. It just has the rust. Michael, you're late. You have to rewatch the first half. What we're talking about is guys are helping out with, I told everybody that if they donated money to one of our reviewers, I Ain't No Punk, Todd, up in Sacramento, he's battling cancer. He's building an LS2. I'm trying to help him out. And I said, whatever people donated, I would match up to $1,000. So people are donating a couple of bucks here, a couple of bucks, whatever they're stepping up and doing. I'll match that, and I'm just going to give it all to Todd so he can get his stuff done and fight cancer. I don't know that all that goes together, but that's what we're hoping for. Richard, good luck to our bud, and thank you for helping out with the Truck Norris report. Good. Hey, happy to help, man. So I had an interesting thing happen to me somebody had watched the videos and stuff. Two cool stories for tonight. One is that I had a guy reach out that has a company that specializes in Mini Coopers. So the 1.6 liter motors, I guess they're made by Peugeot. I thought that they were BMWs, but he said that they're Peugeots, and he wanted me to help him design a head and camshaft package for that, and which wouldn't so that they can improve the power output, yada yada yada. That part of it would not be that hard. Not that I'm going to port the head, but I would have it done and could do the flow testing and development and the power testing and all that stuff on it. And then the camshaft wouldn't be hard to decide what kind of cam specs once I know what the factory ones are. The thing, and this happens quite often, is that was the request. Hey, can you put this together and so that we can sell these packages? Yes, that's not hard. But it turns out because I'm not a mini expert, a mini me expert, it turns out that the program is much more involved than that. It's a direct injected motor. It has a limited amount of injector flow. So that's going to limit power anyways. The person that I spoke to didn't have tuning access directly in their facility, tuning ability. The factory turbo will only support a given amount of power. There has to be a turbo upgrade, but the turbo upgrade must bolt onto the factory, fit in the factory available space, and bolt to the factory exhaust manifold. And so then, and this is only from me, going into detail and trying to find out more information. Then what was once probably something that's fairly simple becomes much more involved because really the heads in the cam are not the problem. The heads in the cam are not the problem with that motor or really any motor. I don't need to know anything about a Mini Cooper engine to know that whatever the factory rated power output is, we can make way more than that with a good turbo and an intercooler and enough fuel and E85 and how we do it. That's not that hard. But being involved in a program like that, I may get somebody else to work with this gentleman. One, it's a time thing for me, although it'd be really cool. I like those cars, but it's a lot more involved. Like, it's easy for me to go in and build the components that I need and test them on the dyno because I have complete control over all of the fuel injection and all that stuff. So I can make the turbo do what I want it to do. Because the other problem that you see is, like, and this was one of my first questions, is that on almost every factory turbo combination that I've ever seen, they all have one thing in common. They all have falling boost curves. They're programmed that way from the factory. So the boost comes up a lot, and so they have a really good torque feel, and then they'll continue to make the horsepower will continue to climb, albeit at a not accelerated rate, but it'll continue to climb despite the fact that the boost typically falls off toward the top of the RPM range. Because I told them, I said, look, if you can just go in and do the programming and make that a flat boost curve, assuming that the turbo will support whatever that flatness is, and it's making the boost that it needs to make out at the top of the RPM range with that available NA power output. If the turbo will do that, then all of a sudden you've made a big change in power. Because if it started out at 15 and dropped down to 8, if you can make it 15 on the top, and the other thing that does is if you run into, because I asked them about ring gap, and I said, look, do these motors break? Yeah, they do. I said, well, this is why they break. They break because of ring gap. And they also break because you have this situation with the boost. When guys turn the boost up, like if you just trick the wastegate like we all do, if you turn the boost up, well, it just raises the whole curve. So it raises the part that's going to build a lot of cylinder pressure and make something break. It raises that one a lot and raises the peak one not as much. I mean, relatively speaking, it might be the same gain if that turbo can support that. It'd be much better off to just like do this. So it still makes that torque, which is probably already good, but it makes more horsepower. I said, you need to do that. And so all of a sudden now it's a whole whole engine development program. So that was one of the discussions I had today. The other discussion I had, I want to make sure that I have the right name here. So I'm taking a look right now. So let's see. So it's I spoke with, and I'm pretty sure his name is Mark from Vortec Pro today, about a peanut port head test that I want to do. And having done the videos I've done already on the big block stuff, where we ran the peanut port head with just like a cam upgrade and stuff, it made over 400, and then with a more serious effort it made over 500. And so I told them, I said, look, what I want to do, and I've seen your stuff, it's really good, and the guy knows what he's doing. He drag races and stuff, and does really good work on the heads. So I told him, I said, look, I want to make 600 horsepower with a peanut port head, because I've done 4 or 5 and I want to do 6, and people love the peanut port head, even though guys are going to badmouth it and say it doesn't work and all that stuff. But if you do a 600 horsepower peanut port head, people are going to like that. The other thing that I want to do that we didn't discuss is I'm going to take a peanut port head and I'm going to make 1,000 horsepower with it with a turbo, which, because I can already make 400 or 500 horsepower with one that I don't have to do any magic to, all I have to do is the turbo is going to do all the magic. The turbo is just going to add 15 pounds or 16 or 17 or whatever I need, and then do 1,000 horsepower with a peanut port head. So that will be fun. And because I think people will like that. They'll be like, oh, really? You can do that? And really, it's, you guys all know that's not magic, but they will think that it is. So it's a good video. But also doing 600 horsepower with a peanut port is something that I've been wanting to do for a long time. So hopefully I will get to work with Mark at Vortec Pro, and that will be cool because he's done a lot of stuff on those already, and he's already done stuff that's been like 585 or 590 or something, and has already put it in. He's got a 68 Chevelle that's already gone out and run 10s with it with a peanut port head, which is, all that's like really kind of awesome stuff. And when he did it with a fairly tiny camshaft. I mean, it was only a 228 cam at 50. So that's pretty impressive stuff, and a dual plane. So it not only did it make that kind of power, it had good torque as well. Shouldn't the poll be can and not will? Can a low compression NA big block make more power on 91? It should say did. Did the low compression NA big block make more power on 91 than 87 octane? We got to do what we got to do. Richard, you should tell everybody about the donation. So we should keep talking about that. Okay, so everybody that's here, what I'm doing is we're trying to raise some money for one of our viewers who has cancer. He also is an LS guy. I've been dealing with him. In fact, I bought a Honda 74 Honda CT90, which I've been out cruising around, and it's like all kinds of awesome. And I want to try to help him out. And so I will match whatever, if anybody donates anything through super chats. If you do, thank you. If you already have, thank you. But if you donate money through super chats, all of it's going to go to Todd. His handle is I ain't no punk. All of it's going to go to him, and whatever you guys donate, I'm going to match. So up to $1,000, let's try to get him some money. And so if you guys have, even if you have a buck, whatever, 99 cents, whatever you got, do a minimum, whatever we can do. We got quite a few people here. Whatever we can do to help him out, I want to help him out. So Mike is saying the BTR tested the truck Norris cam with a stock converter, and the stall made the truck half a second faster. So even the Norris cam likes a stall converter. Did they do that on a 4.8? I remember early on they were testing that on a 4.8. So definitely on a 4.8, I think that camshaft would want. Fastest pen, how do you calculate dynamic compression? Just put up a search for dynamic compression calculator and it will come up. I'm glad no one got abducted last night. Yeah, that was good. I like going, you know, off of our normal regiment of tests. Jerry, thank you very much. Hey, Richard, I have a Junkyard 5.3 with 30 thousandths ring gap, twin GT35, 750 C. What is the 750 CFM? I have oil on a few plugs. Rings, I imagine. What's a low dollar way to go? Gen 4 rods. You shouldn't have oil on your rings. That much ring gap is not going to do that. So something else is going on. My guess is are you drawing oil in through the intake or something? How's your PCV set up? But another way to upgrade, if that's a Gen 3 one, is to put Gen 4 rods and stuff in it. My Apple ID doesn't work. Wallace Racing Calculators does have one. Yep. Richard, I have a 2001 GMC C3 with a stock LQ4 and 4L60E. I saw a video of yours a while back. You're wondering if you have a cam and torque converter stall recommendations for it. LQ4. Yeah, well, you got to tell me what you're wanting to do with it, though. That would decide what kind of camshaft I would recommend for it. There's lots of 6-liter videos up and that give you dyno curves for all of that. So you could pick whatever one you want. Like we ran a stock cam, we ran the sloppy stage 2, we ran a big cam that you could put it in there that's getting near the limit of available piston and valve clearance. We ran a stock LS3, run all of the Brian Tooley Racing stage 1, 2, 3, 4 truck cams in that. You can see what all those did. There's a lot of 6-liter cam information up there that would, you just go, oh, I like that power curve. That one has good down there and it has this here. And that's why I do all that testing. So you could just pick one. And the stall converter is for a 6-liter is going to be this Circle D kind of 2800 or even maybe a little bit less. I think that's kind of a standard size. That Bob Lazar and Richard have a lot in common. How do you degree a camshaft without a dial gauge that goes in the lifter bore? You just need to see when it's moving. So you want to TDC the motor, which doesn't require that. And then once you TDC the motor and get your degree wheel in the right spot, you just need to see when the lifter's moving. But you have to have some sort of gauge to determine that. Which 5.3 is a better model, 06 or 07? The Gen 4 stuff, I don't know really what your question is. I don't know what you mean by better, but a Gen 4 will take more power because it has better rods. And I like the block better because I like the running the same size studs on everything. So as an absolute thing, that one will probably make more power. If you're building an NA motor, they're going to do the same thing. Most customers like the feel of a super fast spooling turbo, so the OEMs put baby turbos on everything. That is true, and especially for the American market, because we're used to big motors with lots of torque. So they want the small motor to mimic that feel, basically, for everybody. Tim, where's the pizza at? Yeah, Mike, water does sit down in those if you don't have, even with those caps in there, which don't seal very well. Brandon, I'm excited. I emailed back and forth to Richard about my build. Turbo will be on it finally this weekend. Good luck, man. Truck Norris versus BTR stage 2 and 3 truck VVT cam and a 6.2 Escalade. I've never run VVT Gen 4 stuff on the dyno. The guys from Brian Tooley might have, but I haven't seen any of that data if they have done the VVT stuff. Free information is always good. Tom, didn't you just tell me that? I should tell everybody about the donations again. Oh, am I way back here? Oh. Dynamic compression calculators are only good at cranking speeds. Just curious. Thanks. Don't worry about it. It's not a big deal. You can tell a lot about a fellow with UFO talk. You can tell a lot about a guy who is open to discussion. Recommendation for a good all-around C6 LS3 cam, no force induction in the foreseeable future. I've got a lot of LS3 cam tests up there also, and really a 6-liter would be the same camshaft. They all work the same way. Mark Sanchez, good evening, Richie. Show me how to send you $100 for your viewer. You can use PayPal if you know how to use that, or this little $sign down here is for super chats. If you can do that, or just don't worry about it and just send it to me or whatever. But I appreciate it, man. Daily drive, mild performance. I don't think I should put too much power in front of the transmission. Then a truck Norris cam would be good for that. What's a good oil pump to run on a 2006 here? Denali 6-liter, refreshing the motor and doing a BTR stage 2. Just wanted to wake it up, nothing crazy. You can just put a stock replacement pump in it then. I think Mellings makes all of that stuff, right? Ryan, doing an LC9 swap with 799 heads in my G8 for a big single. Found an LS3 RCR ported and rod mod intake for a great price. Is it worth buying adapters and running it, or just buying an LS2 intake? Yeah, that intake is not really going to help you, especially with adapters. It doesn't work very well with adapters on an NA motor. I haven't tried it on a turbo motor. The angle of attack and what it has to go through on the adapters is not good. I think it's less problematic the way that they adapt the LSA intake manifold, and it's really short runner. So I think it's less problematic there, but I don't think it's a good choice running the LS3 intake and adapters, because I don't think you're going to gain anything. If the LS3 like worked perfectly and it added 10 or 20 horsepower, it's not going to add 20 horsepower. If it added 10 horsepower, and that's going to be a turbo motor, you're not going to see anything. All you have to do is run a half a pound of boost or a quarter pound of boost or whatever. Where was the map sensor for that centrifugal supercharger big block in the video today? It was in the intake manifold. It was run off of a fitting in the intake manifold. Richard F., if you had to assign it, what stage would the Comp 459? A 231 cam would be at least a stage 4, but it wouldn't be a truck cam. It would be a stage 4, like NA cam, I think. Because I think that those are about, most of those that I've seen are about the limit of what will fit available piston to valve clearance. We used to check actual dynamic compression on a throttle snap to redline. So how are you measuring compression while the motor is running in the cylinder? unless you have something that will measure cylinder pressure. Live close to an Air Force base and they're practicing right now. Well, good. You want them to stay in practice. Ryan, if you have to pick a cathedral LS, then the LS6 or the Dorman LS2 or the Dorman LS6 or the Fast, all of those fit under the thing. Mark, Mark steps up with a hundo. Nice. So Mark just jumped up to the leaderboard and is costing me a lot of money, by the way. Thank you again, man. Do you think that Matt's best cam is too much for a daily driver that sees lots of miles? No, I think that the best cam that he has is smaller than the sloppy stage 2, which I don't think is a great cam for driving around. I think it's much more of a race cam, especially in the smaller displacements. His 219 cam is not terribly big, but still, it's something that's going to need a converter though. You remove one plug and install a gauge. I know that, but it won't be making cylinder pressure, right? It's just, you're just cranking that one. I've seen the hollow spark plug stuff and I've seen them actually measure cylinder pressure. I just wondered if you're just spinning the motor, and that's what he was talking about. Compression ratio on a 5.7 Elm 7 with the heads milled down 30 thousandths. You should be able to calculate that, but that's probably about 6 cc's, I'm thinking. So I think you have only changed it a half a point. I know Mark stepped up his game, right? Mark Sanchez up on the leaderboard. How much can you mill cylinder head for having intake both alignments on a 5.3? Most guys will go 30, and you might have to, on the factory, the nice thing about the factory composite intake manifolds is they're pretty easy to drill out and make the hole bigger. The thing that you might run into is, and we do this a lot, and in fact, we do it on all of the ones that we run on the dyno, we take out the little dowels that are sometimes in the intake manifolds, take those out so that it will just kind of set on there, and then it works pretty well. Dan knows what a picoscope is. It's what you use to look very closely at Pico de Gallo. they're the long tube that goes in the air on the submarine. Do you ever test boost by the centrifugal supercharger outlet versus the intake manifold, or even before and after the intercooler? Yes, an awful lot I do. When we did the intake manifold, when we did the intercooler test, if you take a look at whenever we do intercooler tests, we measure a lot of times temperature before and after the intercooler, and also pressure before and after the intercooler to see what the drop is. A lot of times I won't do it directly before and after the intercooler. I'll do it before the intercooler and then in the intake manifold, because then it also tells me what's happening with the inlet track length. It would be ideal to have it in 3 spots or 4 spots or 20 spots, or more data is always better. But yeah, that's pretty common. 7875 is a T4, at least the Gen 2 one that I have. You can also get S475 stuff in which is a similar size in a T6. Mark Sanchez up on the leaderboard. Let's see. Richard, do you want to test or boost a Samurai engine? Is it a Suzuki Samurai? Those are kind of cool. $10,000 race car challenge on TV. Could you believe that the cylinders blew out of the LS engine? What do you think happened? I haven't seen that. Is that the one that my buddy Chad Reynolds was in? That I think a couple of years. Is that's the one that the guys from Power Auto Media did? Is that the one that you're talking about? Did Mark Sanchez work at Baywood Express 30 years ago? He worked at and still owns Advanced Engineering West. And 30 years ago, he would have been with Chris Kaufman. Show the Suzuki. What motor is in the Suzuki Samurai? Is it a 1.6? What size is it? And is it a 4-valve motor? Frank's saying he's boosted a lot of Suzuki Samurai engines. What pound injectors would be best for an LQ4, mill 317 heads, truck Norris cam, and running the stock truck intake manifold? It's not sure if the truck injectors are, the stock truck injectors are, won't be big enough for that, more than likely. You can do a lot of other, there are other big factory LS injectors that you could use. We put, when we do it, normally we put 80s in it just because we know that we're going to run boost on it. But anything from, let's say 36 on up will work. 36, 46, 50, 1.3 liters. Okay. So is the engine that's in the Samurai, is it the same one that's in the Swift? Oh, a 2-valve. Uh-oh. That's not the Swift engine then. Anyone have a 70Z? I have a 1971 240Z or an FC RX-7 shell they want to part with. A 4.3 liter swap kit. I really want you to test a 13B. Yeah, the Swift had a 1.6 liter. I like those motors, the little twin cams. That's and didn't they make a 1.3 liter that was a Swift engine also? I do want to do a rotary. Swift was a double overcam 1.6. G13A. Okay. See? Did the 4.3 swap to 1. Was a mud truck. Richard, you find a first-gen Honda Insight to put your 3-cylinder turbo motor in. I know, I really would like to. Are pistons with a 105 compression height bad for boost or nitrous applications? The wrist pin is fully into the oil ringland. I wouldn't be worried about that for boost. I'd be more worried about that for oil consumption. Need Richard to test an aviator motor. I'm trying to think. I tested the aviator intake manifold on one of my motors, but not the motor itself. The Geo Tracker. What's the max horsepower high compression NA LS motor I can build? Looking to build one for bracket racing. Do a search for Spinal Tap. That will show you sort of toward the extreme levels of NA LS motors. Insights like K20s, also, yeah, all of those would be good. But I was thinking more for fuel mileage, but a K20 would be good, especially a turbo one. George, I thought that the Swift had a 1.3 twin cam. Admiral wants an Aviator versus an SRX Northstar comparison. What was the Northstar rated at? How much power was it rated at? I mean, I guess I could look that up rather than just asking people. Initially rated at 295 horsepower, the Northstar V8 has grown over the years to an incredible 469 horsepower. That's an STSV. Yeah, that's a different one. I think that's that seems like a lot. The 4-liter is rated at 250. Okay. We use the Vtr head that has a 16 valve, single cam and 16 valve. Northstar is around 300. Yeah, they're showing they showed 290 on the thing that I looked up, but I don't know how absolute it was. Jimmy, I would like to see you test a Ford Triton V10. Probably costs a bunch of pennies though. That would be cool. I do need to do that. All the worst 4-cylinders ever made. I think people would jump in there with the Iron Duke probably. Supercharged version of the XLR was rated at 469. That's what they did say. I was thinking that was the was that the motor that got that Cadillac Supercharger that I ran? We need a rear-wheel drive 4.6 Northstar. I spoke to Turbo Monza today, but he didn't have airflow data yet. Do you have any videos testing the power gains with the Holley Sniper Race Series intake on a 5.3 LM7? The Race Series Sniper intake I ran on the 6-liter Big Bang motor on the that might have been on the Gen 4 motor. I think it was on the Gen 4 motor. It makes less power than a high ram does, and would not be my choice of intake manifolds for a 5.3. Goodman Boat Transport, 1.6-liter Suzuki G16 engine is 1mm bore and 15mm stroke over the 1.3-liter G13 engine. The cylinder heads are interchangeable, but not the distributor and drive housing. See, look at that. We're all learning like Suzuki stuff. It's awesome. Can you run that big block on low compression with a turbocharger on 87? I think we could. I don't know how much boost I would feel comfortable doing on 87, but given the fact that it made the power that it made on 87 and the static compression is low and it has lots of camshaft in it, I think a turbo would work on 87. You just have to be, mindful of the timing. Can a small block Chevy head be made to fit an Iron Duke fairly easily? I don't know. I don't know anything about that. .3 liter Lima engine, the SVO Mustang, Turbo Mustang, or the one that they used in all of the Pintos and stuff, is the Iron Duke's competition. I would pick the 2.3 Ford over the Iron Duke, I think. Yeah, Turbo Monza's in the house. Everyone say hi. I don't. Let me see. The Iron Duke, 151 cubic inch, straight 4 engine. It's an overhead valve, 4-cylinder. Let's see. Oh, no, thereafter, GM's 2.2 liter overhead valve replaced it. When you do a search for that, it says Iron Duke, GM's worst engine ever, question mark. The Fiero. Wow. The ad for the Camaro, little did buyers know that the sports coupe, the Camaro, would develop the reputation of being one of the worst cars of all time. The 1982 Camaro couldn't go from 0 to 60 miles an hour in under 20 seconds. Wow. 0 to 60 in 20 seconds. 92 horsepower, 134 foot-pounds. Well, the fact that it's making more torque than horsepower tells us what about the combination? Yes, it's very. And Mark, thank you very much. Still hitting the leaderboard up there, telling us that it's a very mild combination. This is saying that Camaro, the sports coupe, was the worst car. We used to have an 8-cent lifter tick here for the 2300. This is really good, Cameron. A penny will fit under the lifter. Yeah, you're just shimming the lifter up, which is very cool. Racer D, I just finished dynoing my Iron Duke. It made 222 foot-pounds and 172 horsepower. So tell us what you did to it. Turbo Monza, did you get good news today? If I want to decrease dynamic compression on the 5.3 with a truck Norris cam by retarding the cam timing, how many degrees can I go? I don't know. I don't know what that's going to do. I mean, I know that we know generically what retarding the cam timing does. People are going to give you their opinion on what it might do, but since nobody has probably tested that. The Nomadic Wrencher, curious your thoughts, 318 build going for max horsepower, supercharger, or turbo. How far should I stroke it? Honestly, I wouldn't stroke it at all. If you're building a 318 and you want to, I don't know what you mean by max horsepower. If you want to make lots of power, you should run a turbo because a turbo will make more power than a supercharger. I would keep it at 318 inches. I would put some sort of good cylinder heads on it and put a good camshaft in it, and then put the right size turbo. The turbo then is going to dictate how much power you make. So if you want 1,000 horsepower, you put the 1,000 horsepower turbo in. You want 2,000, you put 2 of those, and away you go. You don't need more displacement or anything with that. If you're going to run a turbo, the turbo will take care of all of that for you. My diesel Audi Q7 took 17.48. I like that you're going to the second decimal point on your 17-second run. Nice. Okay, we're going to close out our poll. So will a low compression and a big block make more power on 91 than 87? 64% saying no and 36% saying yes. So I think the next poll should be, will we ever have a poll that's 100% yes or 100% no? So we'll end that poll. Thank you guys. And thank you guys all for contributing. So I need to figure out how much, thanks for Mark for, for stepping up. That's awesome. And hopefully we'll get some money up to Todd. You can find the dyno testing on YouTube, modified Pontiac Pharaoh 2.5 Iron Duke. It tells the entire story. Okay. What's a good cam for the LQ9 to get 500 to 600 horsepower square port heads? You won't get to 600. You can easily get to 500 and more than 500. Just getting to 600 is hard with just a camshaft. In fact, I've never seen it done with just a camshaft. But 550, 560, 570, that's all of that is possible. And take a look at something like that 469 cam, which is a 231, 247 at 50. Something like that. There are other versions from Brian Tooley Racing, from Cam Motion and Texas Speed and all those places. Just make sure it's a fairly stable lobe, and so that will rev out there nicely. And then if you're wanting to make that kind of power, if you have rec port heads already and you have an LS3 intake manifold, you're already doing fairly well. Racer D, man, I'm happy to help. And I'm going to go check out your, I'm curious now I'm curious what you did to the Iron Duke, because I like running weird motors. Utah County's recommending the Texas Speed Giant Magic Stick. I don't know what the specs are on that, so I've never tested it, so I don't have any data on it. My 318 build is going to be a 99 Magna motor that has 300,000 miles on it. So if it's a junkyard motor, then you're not looking for maximum power. You're just looking for power. Just pick a realistic output and then put a turbo size that's, size it accordingly. Obviously, you're not going for 3,000 horsepower. It's going to be something less than that. So if you need to make 600 or 700 or 800 or whatever, all of that is reasonable. So I'm going to bore it and change the cam for sure. I wouldn't go too big on the bore. Just bore it as little as you need to do. What do you think about a 232, 234? I would go with a bigger split than that. If you have a cam that's for lower RPM and an intake that's for high RPM, what would happen? Well, there's good examples of that, actually. And this will be the last comment that we'll have for tonight, because I've got to get going. There are good examples of that up on the channel when we run intake manifold tests. So when you run an intake manifold test and we go from a long runner intake manifold to a short runner intake manifold, what happens? We lose power down low, and then we make power higher at the top. The exact same thing will happen with a smaller cam. It's just that wherever we make peak power will also be reduced a little bit, even with a short runner intake manifold. But the same thing happens. When you go from a long runner to a short runner, regardless of what camshaft you have, you're going to be trading power somewhere. It's not going to be a lot of guys think that oh, if I do that, that'll be the best of both worlds, because I'll have all the low speed power with the small cam. Possibly, but only in relation to having a bigger cam. Only in relation to having a bigger cam that makes less down there. That's okay. It's okay to look at it that way. But the intake manifold thing is still going to have the same thing is going to happen. If you ran the small cam with the long runner intake and then you put the short runner intake manifold on there, it's not the best of both worlds. What you'll look at it and you'll look at the results and go, oh, all I did was lose a whole bunch of power through most of the curve. And I should have just stayed with the long runner intake with the smaller cam, especially because those two are going to be more closely matched than the other combination. Dyno the Duke. The Iron Duke would be something that I would like to just run and put a turbo on. Same thing with a Northstar. I would also like to just run that and not do ported heads and cams and all that stuff. I would just like to hopefully find a either an Iron Duke, which would be cool, or a Northstar engine that was in good enough shape where I could run 7 or 8 pounds on it and just say, look, we ran a Northstar, it made this power, and we ran boost on it, it made this power. And so if you want to do that, that's kind of what will happen. And then after we did that and it stayed alive, then we would just turn the boost up and see when we heard a head gasket or whatever else is going to happen with it, since I have no idea on either the Iron Duke or on a Northstar engine. Oh, let's see. The Ozman, thank you. Blueprint engines from Kearney, Nebraska. Wow, truckload of 483s. Thank you very much, man. He's going to appreciate this. Oh, now you're in a dulcich moment. Do I grind my own heads or buy aftermarket heads? Again, it depends on how much power you want. Aluminum head would be better on that combination just because you would reduce the chance of detonation if you're going to run boost on it. And if you're going to run boost on it, the need for a better head is less. So if you did like minor work maybe to the head and put a camshaft in it, and let's say you got your 318 to make, I don't know, sub 400 horsepower, 360 or 370 horsepower, whatever the number was. Let's say it made 400. Let's say you did a really good job and it made 400. And then you add boost to that. You can see, start multiplying that out at 15 pounds. If you made 400, you could be near 800. So wherever you want to be, it's fairly easy for you to get there with that kind of combination. And even with a stock head, especially if you did a little porting yourself. Have you ever tested a Wiseco 12cc dome piston? So that's a 6-liter piston with a 12cc dome. I have not. Bring a turbo and we can run it here in Minnesota. I can send you a turbo for that if you don't have one to run it on there if you want to run it. My neighbor had a Dodge motorhome with a 440 and a 671. The mileage was horrible. I would imagine. Paul, thank you very much. What turbo to run on a 318? Just pick whatever power level you want. There's lots of them out there. It's easy to choose. There's no shortage of smart people and help here. So just tell me what kind of power you want, and if you'll run it on the dyno and video it, then I'll definitely do the story on it, or definitely do a thing on it. Turbo Monza, if everyone wants to learn how to port, I've covered a lot and we'll cover more when his health allows. So we're hoping that you get better. I might get a truck nose for my 6-liter Silverado. I know, that's right, Tyler. The more I stay around, it's costing me more and more. Nomadic, I'll contact you on Facebook later. I'm Steven. Good. Just send me an email. My email address is on here. It's easier than sending a Facebook message. I guess that works too. Okay, guys, I got to get going. Thank you all very much for donating. We're gonna get Todd hooked up. I'll need to go through this and figure out how much is there, and then I'm just gonna match it, and we're gonna take care of the guy, man. And I need to see when he's gonna try and put his motor in. If it works out, maybe I can take his LS2 down to West Tech and just run it and do a video on it. And then, he can make sure that it's all working good. And then he could get it in his truck. That would be kind of cool. So thank you guys all for showing up, and thanks for supporting it. We got to, help out the guys when we can, which is super awesome. Thanks again. And I will see you guys all tomorrow. If you haven't, please take a look at the big block video and tell me about the 87 versus 91 Octane. Thanks, guys. I'll see you tomorrow.